Today we're going to do an experiment with reaction time. So we've made some observations about our reaction time. In this case, we have noticed that the more complex a task, the longer it takes us to do it. The more simple a task, it seems like we can react faster, we can do things quicker. For this lab, all you need is a flat surface like a table. You'll want your iPad to do some timing, and you're going to want a deck of cards. Now, if you don't have cards like this, that's fine. You can use cards, like any deck of cards, so long as the cards are a little bit different. The first thing we're going to do in our experiment is simply sort the deck into two piles. All right, so it doesn't really matter what those piles are, but we're going to sort the deck into two piles. Now, I took out the Joker and all those cards. I'm going to shuffle the deck here, and I'm going to time how long it takes me to sort the deck into piles. So what I'm going to do is hit start on my iPad, and then I'm going to just sort the deck. So it doesn't matter what the piles are, it doesn't matter what color comes up next. All I'm going to do is put them into two piles and time it. So you do the same. Just put those cards into two piles and time it and see how long it takes you to separate and sort those cards. All right, now that I have that the deck separated into two piles, I'm going to record that data. So what that is my control. That's going to be the starting point. So I just need to know, like, how long does it normally take me to sort a full deck of cards? In this case, two piles, and I'm going to write that number down. And the next step in my experiment is I want to increase the complexity of the sorting. So in this case, I'm going to sort it so that there's black cards in one pile and red cards in the other. And I want to time, again, how long does this take. So I'm just going to take my cards, and you can decide if you want to have the cards with the back facing up or with the front facing up. It doesn't really matter. So long as you're consistent each time you do it, it makes little difference. All right, so this time I'm going to sort the deck. All the cards that are black go into one pile, all the cards that are red go into the other. And I'm going to hit go, and I'm going to time it. Ready, go. So at some point there, I've got all the black cards in the one pile, I've got all the red cards in the other, and I needed to know how long that took. So I want to record that data. That will be my second experiment that has to do with sorting. Now I'm going to reshuffle these cards. All right, I want to make sure they're pretty shuffled up and mixed in there. And for this final time, I'm going to sort them into four piles, this time by suit. So the hearts will be in one pile, the spades will be in a pile, the clovers will be in a pile or whatever. So I'm going to have four different piles this time. And once again, I'm going to time how long does it take me to get these cards into piles. All right, so I'm just sorting the cards, in this case by suit. All right, so after I finish shuffling the deck up quite a bit, again, it doesn't matter how you have your cards. Like if you have the back facing you or if you have the front, it's not going to make a difference, just as long as you're consistent with your experiment. And then we're going to evaluate this data. All right, so now I'm going to sort them by suit. Ready, go. So now I have all the cards sorted by suit. So I have the hearts in a pile, and I have the diamonds in a pile, and I wanted to see how long that took me. So my hypothesis was the more complicated the sorting, the slower my reaction time would be, because my brain has to spend more processing time figuring out which direction those motor pathways should go. So let's see what your results are. Now that we have some data, we are going to want to put that data into a graph In this case, because we're comparing times, we're probably going to want to use a bar graph. So bar graphs compare, so we want our control time, and we'll probably just make that into a bar graph. We're going to want our first experiment time, that'll be a bar, and then our last one, that will be a bar. So we can compare which sorting time took the longest. So the tallest bar in this case will be the one that took the longest. The longest sorting should correspond with the most processing power, the way it took our brain a long time to process. So see if that's the case or not. And based on that, we can make some kind of conclusion that goes back to our hypothesis. Does the complexity of the sorting relate to the length of time it takes to get the cards into the right piles? Well, we'll see. That's the way science works. Maybe for you, it'll be totally different, and that's why we do it multiple times, so that we can get a general rule for a large group rather than just one individual time where it might have been a fluke, where it might have been that you just shuffled the cards in such a way that it made it way easier to split them into black and red or something like that. So you see what your results are, and you'll let me know.